At 11:47 p.m. Eastern Time, something quietly changed in astronomy. 8 images appeared inside scientific databases around the world. No announcement, no warning, and what they showed wasn't supposed to exist. For the first time, we weren't looking at a blurry dot or a streak of light. These were clear, structured images of an object that came from another star system. Interstellar comet 3I Atlas. And the timing couldn't have been worse, because just 72 hours earlier, scientists completed a scan that had never been done before on an interstellar visitor, a full search for artificial radio signals. The results forced NASA to respond publicly, and reignited a debate that never really ended after Oumuamua vanished in 2017. Harvard astrophysicist Avi Loeb had been asking the question for months. Now, suddenly, everyone had to address it. Was this object just a comet, or something more? Because what the images revealed didn't calm scientists down. It made the situation harder to explain. Jets of gas bending in unnatural ways, brightness changes that broke existing models, and a structure some observers described as uncomfortably geometric. This wasn't proof of anything artificial, but it was enough to trigger the most serious scientific disagreement we've seen in years. And once you see what 3I Atlas revealed, you'll understand why NASA and Harvard are no longer saying the same thing. It started quietly, the way most discoveries do. In July 2025, the Atlas Survey Telescope in Chile detected a faint object drifting through space. At first, it looked routine. Another dim speck, another cold body passing through the outskirts of our system. Then the calculations came in. Its trajectory wasn't elliptical. It wasn't bound to the sunday. It wasn't slowing down. It was moving too fast, and in the wrong direction. Within days, follow-up observatories confirmed what few scientists ever expect to see: a hyperbolic orbit, an extreme velocity, chemical signatures that didn't match anything formed in our solar system. This object wasn't visiting from the Kuiper Belt. It wasn't a rogue comet knocked loose by Jupiter. It came from another star system. Only the third confirmed interstellar object in human history. But almost immediately, something felt off. Unlike Oumuamua in 2017, 3I Atlas didn't just coast through space. It reacted. Jets of gas appeared, but they didn't stream straight back as expected. They curved. They twisted. They bent in directions that made no intuitive sense based on solar heating alone. Even stranger, its brightness didn't behave like a normal comet. Instead of a smooth increase as it approached the sun, it flickered, brightening, dimming, changing in ways existing models struggled to explain. Then came the structure. As higher resolution data arrived, some observers began using an unusual word: geometric. Not sharp edges, not artificial shapes, but patterns that felt organized rather than chaotic. That was the moment the conversation changed, because this wasn't just an interstellar visitor anymore. It was an interstellar visitor behaving differently than anything we'd ever recorded. And that's when one familiar name entered the discussion again: Avi Loeb. The Harvard astrophysicist who once suggested Oumuamua might not be natural looked at the data and made a careful but controversial claim. 3I Atlas deserved a serious techno-signature search. Not a casual scan, not a dismissal. A real investigation. And this time, something unexpected happened. NASA didn't shut the idea down. They listened. And what happened next pushed this object from scientific curiosity to global debate. Once Avi Loeb raised the possibility that 3I Atlas might warrant deeper scrutiny, the conversation shifted behind closed doors. Because this time, the circumstances were different. 3I Atlas wasn't already leaving the solar system like Oumuamua had in 2017. It was still approaching, still observable, still close enough to study properly. And for the first time in history, scientists had the opportunity to do something unprecedented. They could listen. On December 19th, as 3I Atlas made its closest approach, the Breakthrough Listen program aimed the Green Bank telescope directly at the object. A 100-meter radio dish, scanning for the one thing nature almost never produces by accident: narrowband radio signals. These signals are extremely specific. They're tightly focused in frequency. They don't drift randomly. And on Earth, they only come from technology. The scan was precise, intentional. And unlike casual searches in the past, This one was designed specifically for an interstellar object. The data came back on January 2nd. The official statement was short, carefully written, and immediately misunderstood by the public. No credible detections of narrowband radio technosignatures originating from 3I Atlas. To most people, that sounded like the end of the story. It wasn't, because that sentence doesn't say the object is definitely natural. It says no artificial radio signals were detected. That's a critical difference. No signal does not equal no technology. It only means nothing was transmitting in the narrow slice of frequencies we scanned during the short window we were listening. And that's where the disagreement began. NASA emphasized the lack of detections. The conclusion was framed as reassurance. Loeb's response was quieter, but sharper. Absence of evidence is not evidence of absence. And then he asked the question that made scientists uncomfortable. If an interstellar object were artificial, why would we assume it's broadcasting at all? The disagreement never played out in press conferences. It happened in footnotes, in phrasing, in carefully chosen words inside scientific reports. And just as that debate was settling into academic silence, something else happened. New images arrived, and they changed the conversation again. Because once scientists stacked multiple observations from multiple locations, 3I Atlas revealed details nobody had predicted, details that couldn't be dismissed as noise. And that's where things started to get complicated. On January 5th, observatories across 3 continents released a coordinated drop of new data. 8 separate images, 8 different angles, 8 independent instruments. This wasn't a single telescope guessing in the dark. The Gemini Observatory, the Hubble Space Telescope, ground-based arrays in Australia, and even spacecraft positioned near Mars all contributed. When you stack observations like this, something powerful happens. You stop guessing at shape, you start building structure, and 3I Atlas revealed more than anyone expected. The coma, the cloud of gas surrounding the nucleus, wasn't symmetrical. It wasn't evenly expanding the way comet models predict. Instead, jets spiraled outward in curved patterns. Not chaotic sprays, not random bursts. Structured motion. Multiple research teams were careful with their language. They avoided dramatic claims. But the phrasing was telling, non-random, persistent. Unusual compared to solar system comets. The nucleus itself was harder to pin down. Estimates placed it anywhere between 440 meters and 5.6 kilometers wide. That range matters, because if the nucleus is closer to the smaller end, then the amount of gas it's producing makes no sense. Roughly 20% of its surface appears to be actively outgassing. Typical comets only show 3 to 5% activity, 4 times higher than normal. NASA's explanation was straightforward. Different star system, different formation conditions, and they had data to support it. The James Webb Space Telescope confirmed that the ratio of carbon monoxide to carbon dioxide was off by roughly 15% compared to comets born here. But Loeb's team pointed to something else. The outgassing didn't line up cleanly with heating patterns. There were tiny acceleration changes, minute velocity shifts, non-gravitational forces at work. NASA says that's normal comet behavior. Loeb's response was simple. Show me another comet with this exact pattern. And that's where the debate sharpened. Because while no one was claiming 3I Atlas was artificial, no one could confidently say it behaved like anything we'd seen before. What both sides did agree on was this. 3I Atlas is ancient, likely over 7 billion years old, formed before our solar system even existed. It spent eons drifting through the galactic fringe, the cold space between spiral arms where stars die and debris lingers. Then, by pure chance, its path crossed ours, which raises an uncomfortable question. If this object wandered through the galaxy for billions of years, how many others have passed through unnoticed? And how many did we never get a chance to study? Once scientists confirmed 3I Atlas was interstellar, the next question became unavoidable. Where did it come from? The European Space Agency took the lead here, tracking the object with precision far beyond what was possible during Oumuamua's brief appearance. Using updated astrometry and refined orbital models, researchers were able to trace 3I Atlas's path backward through the galaxy. Not perfectly, but better than anything we've ever done before. The result was unsettling. Its trajectory points to the galactic fringe, a sparse, ancient region between spiral arms where old stars die and planetary debris drifts for billions of years. This wasn't a young system ejecting fresh material. 3. I Atlas is a fossil. Likely over 7 billion years old, it formed before our sun even existed. It spent most of its life moving through deep interstellar darkness, passing near stars that may no longer exist today. The system that created it is probably gone. That alone makes 3I Atlas extraordinary. We're not just studying a comet, we're examining preserved material from a place in space and time that has vanished. And yet, it found us. By pure chance, its long, wandering orbit intersected our solar system at exactly the moment we had the technology to notice. Which brings up another uncomfortable reality. Current estimates suggest dozens, possibly hundreds of interstellar objects pass through our system every year. We've officially detected 3. That means we're missing most of them. 3. I Atlas isn't special because it's alone. It's special because we caught it. And for the first time, global observatories were ready. Data flowed in real time between continents. Space agencies coordinated instead of competing. This wasn't luck. It was preparation. And that preparation wasn't just about curiosity, because one day, an interstellar object won't just pass by. One day, it will be on a trajectory that matters. But before 3I Atlas fades back into interstellar space, scientists had to answer one final question. What is it, really? A comet, yes. But a comet that refuses to behave like one. And that brings us to where the debate stands now. Despite the headlines and speculation, there is one thing both sides agree on. 3I Atlas is a comet. Its spectrum shows ice, dust, and gas. Water vapor has been detected. Carbon-based compounds behave mostly as expected. This isn't a metallic object. It isn't a solid slab. It isn't ignoring physics. But that agreement only goes so far. Because while it fits the broad definition of a comet, its behavior sits at the extreme edge of what comets are supposed to do. The activity level is unusually high. The jet structure is oddly persistent. The acceleration doesn't match clean, simple models. NASA's position is cautious and conservative. Different birth environment. Different chemistry. Different thermal history. In other words, strange doesn't mean artificial. Avi Loeb's position is just as careful, but pointed in another direction. He isn't saying 3I Atlas is artificial. He's saying we shouldn't assume it's natural simply because we're more comfortable with that conclusion. His argument is about methodology. If interstellar objects are rare and ancient, then some fraction of them could be technological relics. Not active probes, not broadcasting beacons, just debris. And debris doesn't announce itself. The disagreement isn't about aliens, it's about assumptions. And that's why this debate matters. There's another reason this conversation feels urgent. 3I Atlas is leaving. Right now, it's already past Mars, heading toward Jupiter. In March, it will pass through the giant planet's neighborhood. By 2028, it crosses Neptune's orbit. By 2029, it passes beyond Pluto. And then it's gone, back into interstellar space. We will never see it again. That means every unanswered question stays unanswered forever. There will be no second chance. No follow-up mission. No probe launch fast enough to catch it. This is the cost of interstellar astronomy. You don't get do-overs. That's why 3I Atlas triggered such intense coordination. Every telescope that could observe it did. Every dataset was shared. Because when Oumuamua appeared in 2017, we weren't ready. We noticed it too late. It was already leaving. This time, humanity caught an interstellar visitor in real time. And that readiness wasn't just about curiosity. It was practice. Here's the part that often gets missed. Studying 3I Atlas isn't just about one object. It's about the future. Planetary defense systems exist for a reason. One day, an object won't just pass through. One day, it will be on a path toward Earth. Interstellar or not, preparation matters. 3I Atlas proved something important. Global coordination works. Data sharing works. Rapid response works. And it also reopened a deeper question. How should we approach the unknown? Avi Loeb argues we should treat interstellar objects as potentially artificial until proven otherwise. NASA argues we should treat them as natural unless proven artificial. Both approaches aim to protect science. They just prioritize different risks. Assume natural, and you risk missing something extraordinary. Assume artificial, and you risk seeing patterns that aren't there. Which one serves humanity better? That's not a question science can answer alone. And as 3I Atlas fades, growing dimmer each night, it carries that question with it. Perhaps in millions of years, it reaches another star system. Perhaps another civilization notices it and wonders where it came from, just like we did. So where does that leave us? 3I Atlas wasn't a revelation of alien technology. But it wasn't ordinary either. It was a comet, yes. But one forged in a place we can't recreate, from a star system that may no longer exist, traveling for billions of years before briefly intersecting our lives. NASA says the evidence points to nature. Avi Loeb says nature shouldn't be our default assumption. And the truth is, both positions matter. Because science doesn't move forward by certainty. It moves forward by questions that refuse to go away. 3I Atlas reminded us how small our window really is. A few years of observation, a handful of images, then it's gone forever, carrying its answers back into interstellar darkness. But it also showed something else. When the next interstellar visitor arrives, and it will, we'll be ready. We'll see it sooner, study it deeper, and ask better questions. So now the question is yours. When something ancient enters our solar system from the depths of the galaxy, should we assume it's natural until proven otherwise? Or treat it as something extraordinary until proven mundane? Because how we answer that question may shape what we discover next. Let us know your thoughts below. And if you want to stay ahead of the next visitor, subscribe, because the universe isn't done surprising us yet.